Hi, everybody. Mr. Sisler here, and we are going to go over your 1.5 notes. We're going to be graphing some inequalities, looking at some compound inequalities, and wrap it up with a couple of word problems. So let's begin with some review. All right, so first things first, we're just going to graph some inequalities. So our first one reads x is less than or equal to 4. Right? So all we have to graph is a 0, just kind of as a reference point, and our number 4. So that's 1, 2, 3, 4. That is a terrible 4. I'm going to fix that. Okay, 4. And we're going to fill in our circle because it is less than or equal to. So if we have that or equal to, we fill in our circle. And x is less than or equal to 4, so we're going to shade in all of that. Okay. Next one, we have y is greater than -5, so we're going to plot our 0 for our reference point. 1, 2, 3, 4, -5. This time we are not going to shade in our circle because there is no greater than or equal to. It's just y is greater than -5. And we're going to shade in all of our values that are greater than -5. Okay, for C, we are going to, first things first, let's reflect our inequality so that it's something that we're more comfortable with reading. And we're going to make it x is greater than or equal to 4. So we always want to go left to right when we're graphing our inequalities and reading inequalities. Otherwise, we can get pretty easily tripped up. So I'm going to plot my 0, then 1, 2, 3, 4. I'm going to shade in my circle because it's greater than or equal to. And then we're going to shade to the right because we're shading values that are greater than or equal to 4. Next, we have 2 is less than x, which is less than 7. So we have 3 numbers to graph. We're going to graph 0, we're going to graph 2, and we're going to graph 7. Okay? Both of these get an open circle because there's no, again, greater than or equal to. There's no less than or equal to. And we're going to shade in between those, right? Because the numbers here, which would be 3, 4, 5, and 6, all of those are the only numbers that are both greater than 2 but less than 7. Okay? So let's solve some inequalities. So the solution to an inequality is all of the numerical values, so all of the numbers, that make the inequality, and I'm going to abbreviate, true. So in our example, we have x is greater than a. So I'm going to plot my 0, and I'm going to plot a, just assigning it kind of a random value. A gets an open circle because it's just greater than. And then our solution is all of the values to the right, which is where I'm shading, because those are values that are larger than a. Okay? Next, we have what are called exclusive and inclusive boundaries. And before I get that, I just want to remind you that if there's a concept that you don't understand or that you need to go over again, you can always pause Edpuzzle and rewatch. You can also access these notes at any time on Edpuzzle. And of course, Mr. Schmalzer and I are very responsive to emails if you want to reach out and ask a question. Or you can ask during class, of course, right? So we have exclusive boundaries. So we have that word in there, exclude, right? So it means does not include. So exclusive boundaries are our less than and our greater than. And in this case, the boundary value is not part of the solution. And as we saw in our examples above, when we have greater than or less than with no line underneath it, we use an open circle. And then on the other side, we have inclusive boundaries. So that's going to have that word include in there. Okay. And in this situation, we do have our lines underneath, which signals greater than or equal to. And in this case, the boundary value, which is just the number on the other side of the inequality, is part of the solution. And again, as we saw in our examples up top, we're going to use a shaded or closed circle for this, right? So when solving an inequality, we're going to solve this like a normal equation. Okay, so let me show you what that looks like. So we have 2x minus 5 is greater than 1. So just like a normal equation, we're going to add 5 to both sides. So we get 2x is greater than 6. And we're going to divide by 2, and we're left with x is greater than 3. There is an exception to this. So when we multiply or divide by a negative number, we flip the direction of the inequality sign. And again, I'm going to abbreviate inequality. So in this example, we have negative 3x is less than or equal to 18. So I'm going to divide by negative 3 on both sides, and we end up with x. We have to flip that sign, right? So this reads less than or equal to, but because we divided by a negative, we got to flip that sign, and we end up with x is greater than or equal to negative 6. Okay? Oh, caught my mistake. Give me 1 sec. I gotta erase these examples. 1 second. Okay, so we have some examples. I'm gonna do the first one for you just to model it, and then I'm gonna ask you to do the rest yourself. So first we have 6 parentheses x minus 4 is less than 18. So remember, we want to show all of our work first of all. Just remember, the way we teach Algebra 2 at GBS, really all math classes, is we're more focused on the process than the final result. So we want you to show all of your work, even if you feel you can do it in your head. It is always best to show your work so we understand your thinking, right? Okay, so first we need to distribute. So we get 6x minus 24 is less than 18. We're going to add 24 to both sides, so we get 6x is less than 42. And if I'm going too fast, just hit pause so that you can kind of control the pace. Remember, that's a great thing about Edpuzzle notes. And we end up, after we divide by 6, we end up with x is less than 7. So we're going to plot our 0. We're going to plot 7. 7 gets an open circle because it's an exclusive inequality, exclusive boundary rather. And then we are going to shade to the left because those are all of the values that are less than 7. Okay? So This will be a good time to pause so that you can go ahead and practice on your own, and then we'll check your work to see how you did, all right? Okay, so for example B, we have -2 parentheses x minus 4 is less than or equal to 28. So let's distribute so that we get -2x plus 8 minus 3x is less than or equal to 28. We'll combine our like terms, so -2x minus 3x is -5x plus 8 is less than or equal to 28. Subtract 8 from both sides, so we get -5x is less than or equal to 20. And we are going to divide by -5 on both sides, so that we get x is less than or equal to -4. Plot my 0. 1, 2, 3, -4. -4 gets a shaded circle because it's less than or equal to. And we're looking for values that are less than or equal to -4, so we're going to shade to the left. Okay? All right, go ahead and do C on your own. All right, so for C, we have 6x minus 12 is greater than 4x minus 22. So I'm going to subtract 4x from both sides, and we end up with 2x minus 12 is greater than -22. Going to add 12 to both sides, and we end up with 2x is greater than -10. Divide by 2, and we get x is greater than -5. Going to plot my 0. Going to plot my -5. -5 gets an open circle, and we're looking for values that are greater than that number. So we're going to shade to the right. Okay? Go ahead and try D. All right, so for D, we have 2 parentheses x minus 3 is greater than or equal to 3x minus 6. So we are going to distribute 2x minus 6 is greater than or equal to 3x minus 6. We are going to subtract 3x from both sides. So we end up with -x minus 6 is greater than or equal to -6. Next, I'm going to add 6 to both sides, and we end up with -x is greater than or equal to 0. I'm going to draw an arrow to finish it over here. We need to divide by -1, because again, that -x is the same thing as -1x. So we divide by -1 on both sides, and we end up with x. We have to flip the inequality sign because we divided by a negative. So x is less than or equal to 0. So I'm going to plot my 0. It gets a shaded circle because it's less than or equal to. And then I'm going to shade to my left because we're looking for values that are less than or equal to. Okay? So again, if you have any questions about those examples or anything else, please let us know. All right. Next, we're going to look at solving compound inequalities. So same skill process. It's just there are a couple of extra steps. So with compound inequalities, we have either and inequalities or inequalities. So our and inequalities is a case where we have an overlap of the solutions of both inequalities. And what that means, if we look at our example down here, what that means is 2x plus 6, right, is both greater than -4 and 2x plus 6 is less than or equal to 14. Okay? So that means there are multiple, there's an overlap again. So I'm going to solve this one, walk you through it. So we want to start with our the part of our inequality that has the x variable. So I'm going to start by getting rid of this 6. So I'm going to subtract 6 from all sides. We end up with -10 is less than 2x, which is less than or equal to 8. I'm going to divide by 2 on all sides to isolate the x. So then we end up with -5 is less than x, which is less than or equal to 4. And the way that that looks on a graph, we have 3 numbers to plot. I'm going to plot my 0. I'm going to plot my 4. And I'm going to plot my -5. Okay, so -5 gets an open circle because that part of the equation is just less than. 4 gets a shaded circle because it reads x is less than or equal to 4. Okay, so for -5, we want values. So I'm going to shade in this whole region because the numbers in there fit both criteria. So the numbers in there are both greater than -5, which comes from this part of the equation, okay? And the numbers in there are less than or equal to 4, which comes from that part of the equation, okay? So let's try one more. So in this case, we have -4x is greater than or equal to 8. And we have 3x is greater than 15. So in this case, we solve these separately. So we have -4x, I'm going to divide by -4 on both sides. And we're left with x. And remember, we're going to flip that inequality sign because we divided by a negative. So it's less than or equal to -2. Or we're going to divide by 3. And we're left with x is greater than 5. Okay, so again, I have 3 numbers to plot. I'm going to plot 0. I'm going to plot 5. And I'm going to plot -2. -2 gets a shade. +5 gets an open. I want numbers that are less than or equal to -2. So that means I shade over here. And I want numbers that are greater than 5. So I shade over there. Okay. So why don't you all work through examples 2A, B, C, and D. Enter those in on Edpuzzle, and then we will go over the answer to those, okay? Okay. So first for A, here's what we do for A. So it reads, -12 is less than or equal to 3x minus 9, which is less than or equal to 6. So this is an AND problem. So first we need to isolate the x. So we're going to add 9 to each side. We get -3 is less than or equal to 3x, which is less than or equal to 15. We're going to divide by 3. and we are left with negative 1 is less than or equal to x, which is less than or equal to 5. Plot my 0, plot my negative 1, plot my 5. They both get shaded. And when we have an and, we're shading in between. Okay? So what that means is the numbers in between negative 1 and 5, along with the numbers negative 1 and 5, would work if you plug them into that equation. Okay? Go ahead and do example B. Okay, so for example B, we have 2x minus 1 is less than negative 7, or negative 4x minus 2 is less than negative 6. So we solve these separately. So we add 1 to both sides. We get 2x is less than negative 6. Divide by 2. And we get x is less than negative 3. On the other side, we're going to add 2. We get negative 4x is less than negative 4. Divide by negative 4. So we get x. I've got to flip my inequality because we divided by a negative. X is greater than 1. So we end up with x is less than negative 3, or x is greater than 1. So I'm going to plot 0, going to plot 1, going to plot negative 3. They get open circles, shade to the right, shade to the left. Okay? Go ahead and do C. All right, for C, we have 3x minus 1 is greater than negative 4, and 5x minus 10 is less than 15. So isolate our x, we add 1. We get 3x is greater than negative 3. Divide that by 3. And we get x is greater than negative 1. I'm going to put my and there. We're going to add 10 to this side so that we get 5x is less than 25. Divide by 5. And we get x is less than 5. Okay? So I'm going to plot 0, plot my negative 1, plot my 5. We don't shade them. And again, this is an and problem. So our solutions overlap, which means I'm going to shade in between. So another way of saying that is the numbers in between negative 1 and 5 would work for both inequalities here. So if we take the number 2, for example, if we plug in 2, we would get 2 is greater than negative 1, and 2 is less than 5. Okay, so that's just another way of looking at it. All right. Next one is a few more steps because we've got to distribute, but it reads 8x plus 16 is less than or equal to negative 24, or negative 3x plus 4 is less than or equal to negative 9. So we subtract 16 from both sides. We get 8x is less than or equal to negative 40. Divide by 8, divide by 8. And we get x is less than or equal to negative 5. Or let's distribute. So we get negative 3x minus 12 is less than or equal to negative 9. We got to add 12, add 12. We get negative 3x less than or equal to 3. Divide by negative 3. X. So we got to flip our inequality sign again because we divided by a negative. So it reads x is greater than or equal to negative 1. So that should be your solution. we'll plot our 0, plot our -1, and plot our -5. Both of these get shaded. And we're going to shade to the left of -5 because we want numbers that are smaller than that. And we're going to shade to the right of -1. Okay? Awesome. Let's work through number 3 together because it's a word problem and we haven't done that yet. And then you'll do number 4 on your own. So number 3, a carnival is having a game that says contestants must be at least 6 years old, but not more than 52 years old. Write an inequality to describe this situation. Okay, so first I'm going to annotate my problem. So I'm going to annotate at least 6 years old. Okay, that at least tells me that it's a case where we're going to have either less than or equal to or greater than or equal to because it includes that 6 years old. All right, sorry, I had to pause there for a second. So again, I annotate at least 6 years old, but not more than 52 years old. So again, that not more, it tells me that we're going to include 52 in our solution, okay? So what we end up with, let's plot our x. So we end up with 652. So in relationship to x, which is the age that you have to be to play the game, you can play the game if you are 6 years old or older. So x is going to be greater than or equal to 6. And you can also play the game if you are 52 or younger. So x is going to be less than 52 or equal to 52. So the way we would read that is 6 is less than or equal to x, which is less than or equal to 52. In other words, with the real life application, if you are 6 years old or less, or 6 years old or more, you can ride the ride. If you are 52 years old or less, you can ride it. Okay, if you're younger than 6, that doesn't work, right? So if we plugged in the number 5 for x, so let's say x equals 5, that would read like this. 6 is less than or equal to 5, which is less than or equal to 52. So that just doesn't work, right? Because 5 is not greater than 6, okay? So I'm going to erase that part. Why don't you go ahead and try number 4 on your own, and then we'll come back. All right, so number 4, check your work. So we have a water park has a slide that has 2 types of restrictions, one for height and one for weight. The sign reads as follows. Riders must be at least 48 inches tall. So again, I have that at least. Wow, major voice crack. We have at least 48 inches tall. And they must also weigh more than 100 pounds. So that more than tells me that x is going to be greater than 100, but not exceed 350. So they cannot be more than 350 pounds. So that tells me x has got to be less than or equal to 350. So let's write an inequality for the height. All right. So x is the height that you have to be to ride the ride. And in order to ride it, you have to be more than or equal to 48 inches tall. Okay? So for part B, This is going to be a compound inequality because we have two numbers. So we need to write an inequality for the weight restriction. So we have x. We know you have to be more than 100 pounds. And we know that you cannot be more than 350 pounds. Okay? So go ahead and check your work. If you have any questions, do not hesitate to reach out to us. Ask us in class, ask us via email, whatever you're comfortable with. And yeah, we will see you in class next time.